Hello everyone. So in this tutorial, we'll see about VLSI lab and we'll execute some experiments. Hello everyone. So in this tutorial, we'll discuss about VLSI lab. We'll start with part A, that is digital design. So to execute the experiments, we have to first install models and software on the system. So I have installed ModelSim software, that is ModelSim SE 64-bit 10.4 version. So double click on this application, maximize the screen, then go to file, go to new, inside new, go to project. You'll get a pop-up window like this. Then give the project name as lab 1. Keep the rest of the settings as intact. Keep the remaining settings as it is and click OK. Click Yes. Then we'll get this window. Then click on create new file. Give the file name as inv and change the add file as type to Verilog. Change the VHDL to Verilog and click OK. Close this window. Then you'll see a file that is inv.v. .v stands for Verilog file. Then to write the code, double click on this file. You'll get a window, a blank window. You can drag this window to the left hand side and write the code. So we'll start with the inverter. So already have written the code for inverter. Just will copy paste it and execute the code. This is the code for inverter. So this is the Verilog code for inverter, which is written in behavioral style. Okay, so it will start with model, the model name. Then inside we have input output parameters. Then we have always at, so it depends on the input A. So if A means if A input is high, then output should be 0, else output should be 1. Okay, so this is the code. Save it, then go to compile, click on compile selected. You can see at the bottom in the transcript window, you'll see compile of inv.p was successful. If you get this message, go for the next step. So next step is to simulate the code. Go to simulate in the toolbar, click on simulate, then go to start simulation. Then inside that start simulation, you'll get this window. Then click on this work, go inside to work folder, click on this plus sign, then click on inverter. Click on this inverter, whatever the whatever the model name you have given, that is inverter here. Click on that, then uncheck this enable optimization and click on OK. Then you'll get this windows like simulation default. So we have a file inverter. Right click on this inverter, then go to add to wave all items in region. So you can see that we have to parameters here. One is input, that is A, and one is output, that is phi. So right click on the input and click on clock. You can change the duty cycle period of this signal, that is input signal, that is A. We can change the period and the duty cycle here. So I'll keep the default values and click OK. So please remember, apply the clock only to the input signals, not for the output signals. Click OK. Then, so we have applied the clock for the input signal A. Then just run the simulation by going to this icon. So in the toolbar, if you see 100 nanosecond on the right side, there is a icon to run the simulation. Click on this run option. So you can see you're getting some waveforms. So click again. You just click the run simulation icon. Just click that. You'll see the output. So this is the output for inverter. So this is the half part of the first experiment. The other half part, we have to write the test bench and verify the output, whether we are getting the same output of inverter or no. To write the test bench, go to first end the simulation. So to end the simulation, go to simulate and click on end simulation. Click on this simulation, then click S. So you'll come back to the original window, that is the code window, editor window. Then we have at the bottom of at the left corner we have library and project. So click on this project so you can see your file, that is inv.p file. So inside this window, in the project window, right click, then go to add to project, new file. Add to project, new file. Then you give the name of the inverter test bench as inverter underscore tb. Give the test bench name as inverter underscore tb. Then that is the file name. Then again you select Verilog, because all the code we are writing in Verilog language. Select Verilog, then click OK. So you can see that inverter underscore tb is created, the file. Then to write the code for test bench, double click on this file and just write the code for the test bench. So copy the test bench code from here. Just I will copy the code and paste it here. So this is the code for test bench, inverter test bench. So it will start with again model, the test bench name. We can give any name for this. So I given here inverter underscore TP. Then resistors. So whatever the inputs are there, if you define in terms of resistors, then the output in terms of wire. Then so we have to call whatever the name we are given for the main function. That is the design unit. That is the whatever the name we have given. So if what are the name here we have given here, inverter. So the same name we have to call in the test bench. So that is inverter. Okay, whatever you call here, that is the model name, that is inverter here. So the same name you have to call it here in the test bench. If you give the different name, you'll get the error, design not found error. So again, then you define the truth table for this. So define the inputs or the test signals. These are the test signals. So I'm defining at 0 nanosecond the input to be has 0. Then after 10 nanosecond the input to be is 1. Again after 30 nanoseconds, the input to be 0. Again at 40 nanometer, the input to be 1. Okay, so the input will change at the time intervals, at different time intervals. So save this and you go to compile. Again, you compile selected. Go to compile, then you click on compile selected. Then you can see compile of invert underscore tb.p was successful. Okay, whatever the file name we have, the invert underscore tb was successful. So that is what we'll get the message here. So we have to simulate it here now. Go to simulate, start simulation, then go to work, then whatever the model name we have given for Testbench, that is the invert underscore tb. So select that invert underscore tb, then click OK. Right. So you can see invert underscore tb, the file or the model name here. Then right click on that file, then go to add to wave all items in region. Okay. Right click on the model name, invert underscore tb, then go to add, then go to wave, then go to all items in region. Then you can see the signals, yes, that is input signal and the output signals. So in Testbench, please make sure that we should not apply the clock signals, because already we have defined the input signals here, which is defined at particular interval of time, that is 10 nanosecond, 20 nanosecond, 10 nanoseconds. So no need to apply the clock for Testbench. We should not apply. You will get directly the output, because the test signals are applied in the code itself. So this directly, so after add to wave all items in region, so directly click on run. You can see the output here. We can see the output. So if I click here, if I click on here, so we can see when the input is 0, the output is 1. So look at this part A. When the input is 0 here, look at the cursor. When the input is 0, output is 1. When the input is 1, the output is 0. So we can cross verify with the waveforms too. So this is the first experiment of VLSI lab, that is part A, digital design, inverter and its test bench. Thank you everyone.